In lesson 7-2, we're going to talk about factoring quadratic expressions. So here are the three different forms of quadratic expressions we're going to talk about. And there's three different ways to factor those three different forms. But before we talk about those different forms and factoring them, we're going to talk about greatest common factor, because that's the thing that we're going to do before we do anything else. Greatest common factor, or GCF, you should remember, is the greatest factor that every term has in common. So it's the greatest, it's exactly what it sounds like. It's the greatest factor that every term has in common. And this is the thing that you always want to look at first. So you always want to look for the GCF first and pull that out before you do anything else. So always look for GCF first before you do anything else. Super important. 5 exclamation points, important. And I'm going to highlight it. Very important. Do that first. All right, let's look at an example. Example 1. I want to factor this expression. First thing I'm going to do is I'm going to break down each term in this expression into its smallest factors. So looking at the first term here, I'm going to look piece by piece. I'm going to look at the 5 first. Can I break that 5 down further? No, I cannot, because it's prime, so I leave it as 5. That's my factor. I have next this x cubed. X cubed means I'm multiplying x times itself 3 times. So I have 3 x's multiplied together. Then I have y squared, which means I have 2 y's multiplied together. That's my first term broken down into all its factors, its most simplified factors, or smallest factors. For my second term, I'm going to look at this 10 first. Can I break that down? Yes, I can. I can break it down into 2 times 5. That's the smallest factors. Those are both prime numbers, 2 and 5. Can't be broken down further than that. I have 1x being multiplied and 3 y's being multiplied together for that second term. Now I want to look for what these have in common. I'm looking for what they have in common. That's what the C stands for. So I'm going to look at what's similar. What factors do they share? In the first term, I have 1, 5. In the second term, I have 1, 5. They share a 5 in common. The first term and second term also share an x in common. And then they share 2 y's in common. And now I'm going to, so that's collectively, if I look at those factors that they have in common, collectively, together, they are the greatest common factor. So 1, 5, 1x, and 2 y's, or 5x, y squared, that is the GCF. Then after I take that GCF out, I want to see what am I left with for each term. Well, my first term, I'm left with 2 x's multiplied together, and I just write that as x squared. So x squared times 5x y squared gives me this. But for my second term, I'm left with a 2 and a y multiplied together, which is just 2y. If I multiply 2y times 5xy squared, I get my second term. I took out that 5xy squared, and I was left with x squared plus 2y when I did that. X squared and 2y, sometimes I don't take out the right thing. Sometimes I make a mistake with my GCF. But if you look inside of your parentheses and the two terms share nothing in common, you did it right. X squared and 2y don't have any factors in common, so we did it right. For the second example, I have 8x squared y and 4xy cubed z. I'm going to break them down into their smallest factors. So I'm looking at the 8 first. I'm looking at the numbers in the front first. 8 breaks down into 4 times 2. So on the side, I'm going to write this. Breaks down into 4 times 2, and 4 breaks down into 2 times 2. So I know that I can break 8 down into 2 times 2 times 2. That's its smallest factors that it breaks down into. So 2 times 2 times 2. I have 2 x's being multiplied together, 1 y. And then my second term, 4 breaks down into 2 times 2. I have 1x, I have 3 y's, and I have 1z. Now I'm going to look for what they share in common. I have 2 2's in common, I have 1x in common, and I have 1y in common. So the GCF is those factors together. So 2 2's, 1x, 1y, which collectively gives me 4xy. That's my GCF. And then I write what's left in parentheses in those two terms. So I have 2 and x left in my first term. So that's 2x. That means 2x times 4xy gives me my first term. And then for my second term, I'm left with y squared z. 2x and y squared z have nothing in common, so I took out my GCF correctly. This is the factored form. All right, now let's get into the good stuff. First thing I want to do is I want to factor quadratic expressions in the form ax squared plus bx plus c, where a is equal to 1. So that's where the coefficient for x squared is equal to 1. All right, I'm going to do what I already know to start, and then I'm going to see if I can look for a pattern. I know how to go from factored form to the area square, to the expanded expression, to the simplified expression. I know how to FOIL this thing. So I'm going to do that. I have x plus 2 times x plus 7. I set that up in my area square as the side lengths, and I multiply each term together. I have x times x gives me x squared. X times 2 gives me 2x. 7 times x gives me 7x. And then 7 times 2 gives me 14. In expanded form, so expanded expression, I'm going to write x squared plus 2x plus 7x plus 14. That's just what I see in this box. All those areas added together. The simplified expression, I'm going to collect my like terms in the center, the middle terms. So I have x squared plus 9x plus 14. Then I'm going to look at my second example. I have factored form. Doing my area square, I'm doing x times x is x squared. X times 5 is 5x. Negative 9 times x is negative 9x. Negative 9 times 5 is negative 45. Expanded expression, I'm just adding all those terms together. I have x squared plus 5x minus 9x minus 45. And then the simplified expression, I'm collecting my x terms. And that gives me x squared minus 4x minus 45. All right, so now I have this table filled out. I want to see if I find a pattern. Ideally, I would be able to move from simplified expression directly into factored form. So I'm going to see, is there some way I could do that? I'm going to look at my simplified expression for anything that I notice, or I'm going to look at what's unique about my simplified expression. So the thing that makes this quadratic expression unique is the 9 that's in front of the x, or sorry, the plus 9 that's in front of the x, so the positive 9, and the plus 14. What makes my simplified expression for the second example unique is the negative 4 in front of the x and the constant at the end, negative 45. If I look in my factored form, what makes the factored form unique is the plus 2 and the plus 7 in the first example, and in the second example, the plus 5 and the minus 9. Those factored form usually for quadratic expressions is just x by itself. So that's not fancy or unique. Just the 2 and the 7 are unique, and the 5 and the negative 9 are unique. I want to look for if I see a pattern in my simplified expression and my factored form. So do I see 2 and 7, a pattern with 2 and 7 in my simplified expression? So do I see 2 and 7 in my simplified expression here? Well, I'm going to look at what's unique in the simplified expression. So I'm going to look at the plus 9. Is there something I can do with 2 and 7 to get 9? Yes, there is. I can add them together, right? Is there something I can do with 2 and 7 to get 14? Yes, there is. I can multiply them together. What about in my second example? Is there something I can do with, now the unique numbers that I have are 5 and negative 9. So is there something I can do with 5 and negative 9 to get negative 4? Yes, there is. I can add them together. And then is there something unique I can do with 5 and negative 9 to get negative 45? Yes, there is. I can multiply them together. Did I do the same thing in both of these? So I added the two numbers in factored form together to get b, because I know this is the form ax squared plus bx plus c. So I added the two numbers in factored form together to get b, and I multiplied them together to get c. Same thing in the second example. I added the two numbers together to get b, and I multiplied them together to get c. So if we have an expression in the form ax squared plus bx plus c, where a is equal to 1, it is for these two examples, I have 1 as the coefficient for x squared. To find the two constants in our factored form, so 2 and 7 and 5 and negative 9 in these examples, we need to find two numbers that both, first thing, add up to b, right? They have to add to b, and they need to multiply to c. Multiply to c. When we need two numbers that add to something and multiply to something else, we can use that diamond. So that's why we can use the diamond for this. That diamond, that looks like this. We need two numbers that multiply to c and add up to b. So this diamond just says it's two numbers that, if you forget what the diamond means, that multiply to this and add to that bottom number. Okay. All right, so let's try an example. We're going to go from the simplified form. So we're going to go from the simplified form back to the factored form. We have x squared plus 8x plus 16. And what we're going to do is we need to find two numbers that add up to b and multiply to c, and those are going to be, that's directly, we can go to factored form from there. We're going to use our diamond to get there. So with the diamond, I'm looking for two numbers that multiply to 16 and add up to 8. And those two numbers are 4 and 4. These numbers are immediately going to tell me what's in factored form. So I know in factored form, my first term inside the parentheses is going to be x. And I'm going to add 4 in the first one, and I'm going to add 4 in the second one. These numbers that I find tell me directly my factored form, and this is my final answer. For example 2, I have x squared minus 3x minus 10. I'm going to use my diamond. I need two numbers that multiply to negative 10 and add up to negative 3, which is b. Negative 10 is c. Negative 3 is b, just in case you need to see this like this. Oh, oops. Plus bx plus c. C is negative 10, b is negative 3. And a is 1. All right, I'm looking for two numbers. I have, the two numbers are negative 5 and positive 2. They add up to negative 3 and multiply to negative 10. That tells me these are the numbers in my factored form. My factored form, first term inside the parentheses is x. In one, I'm going to have negative 5 minus 5. And in the other, I'm going to have plus 2. And this is my factored form. All right, next we're going to talk about factoring quadratic expressions in the form ax squared plus bx plus c, where a is not equal to 1. So where a is not equal to 1. It's something else. So first we're going to do what we already know again. We're going to go from factored form to the simplified expression. So I have 2x times 3x, which gives me 6x squared. 2x times 2 gives me 4x. Negative 4 times 3x gives me negative 12x. And negative 4 times 2 gives me negative 8. Sorry, I'm getting out of breath because this is my 5th time trying to record this video. I keep on going on tangents like I'm doing right now. Next, I'm going into expanded form. I'm going to take these and add them together. Just rewrite them over here, add it together. 6x squared plus 4x minus 12x minus 8. And then the simplified expression is 6x squared minus 8x minus 8. Next, I have 3x minus 3 times 3x plus 2. 3x times 3x gives me 9x squared. 3x times negative 3 is negative 9x. 2 times 3x is 6x. 2 times negative 3 is negative 6. The expanded form is 9x squared minus 9x plus 6x minus 6. And the simplified form is 9x squared minus 3x minus 6. And then last, I have 2x minus 3 times x minus 5. 2x times x is 2x squared. X times negative 3 is negative 3x. 2x times negative 5 is negative 10x. And negative 5 times negative 3 is positive 15. If I add these all up, my expanded form is 2x squared minus 3x minus 10x plus 15. And then the simplified form is 2x squared minus 13x plus 15. All right, now that I have this filled out, I'm gonna look at it for some patterns. I want to look to see, is there any way I could go from simplified expression back to factored form? Because that's what I want to be able to do, because that's the easiest thing to do. So I'm going to look at the unique things that I have in factored form and the simplified expression. Do I see any pattern? Any patterns between the simplified expression and the factored form? Well, one thing that I do see is the first two terms multiply together to be the first term here. The second two terms multiply to be my constant. But is there a way that I can take that middle term, negative 8, and get back to my factored form, or that negative 3, and easily go back to my factored form? No, there's too many numbers here, too many things going on. I can't go directly from simplified form to factored form unless I guess and check. But there isn't one perfect way to always go back from simplified expression to factored form. So I'm going to look at the expanded expression. Maybe I can go back from my expanded expression back to factored form. So I'll have to do one extra step than I would if a was equal to 1. So let me look at expanded expression. Well, I'm going to look for a pattern that I see in expanded expression. If you look at the question below, in the expanded expression, what pattern do you notice? Let's give away the pattern here, what you're supposed to be looking for. You look at the pair of outside numbers and the pair of inside numbers. Ideally, we would have done this in a classroom, and you would have really analyzed this thing, but I'm not going to waste your time. So I'm just going to tell you, if you look at the pair of outside numbers and the pair of inside numbers, you should see a pattern in the expanded form. So if I look at the outside numbers, I have 6 and negative 8, 9 and negative 6, 2 and positive 15. And then if I look at the inside numbers, I have plus 4 and negative 12, minus 9 and positive 6, negative 3 and negative 10. I'm going to look if I see a pattern between those. So I'm going to write them out. I have 6 and negative 8. I have 4 and negative 12. I have 9 and negative 6. Then I have negative 9 and positive 6. And then in the last one, I have 2 and 15. And I have negative 3 and negative 10. What have I noticed about these pairs? In the first example, if I multiply 6 times negative 8, I get negative 48. If I multiply 4 times negative 12, I also get negative 48. In the second example, if I multiply 9 times negative 6, I get negative 54. If I multiply negative 9 times 6, I also get negative 54. And in the last example, same exact thing. If I multiply these together, I get the same thing. If I multiply those two numbers, I get the same. So that's the pattern that I see in expanded form. but I need to be able to go from simplified form to factored form. So I'm going to look in simplified form, and I'm going to try to find a way to get back to expanded form. I know that 6x and negative 8x, the numbers on the outside, are still present in the simplified form. They're still present in the simplified form. I need to be able to use A, B, and C to go backwards. So talking in terms of, and if I look back at my ax squared plus bx plus c form, I used the diamond. I just used whatever the c term was to find what I needed the numbers to multiply to. And I used whatever the b term was to find what they added to. Here, the b is the same. I'm still looking for two numbers that add up to that middle term b. And then I know that the outside numbers are going to be what I need those two numbers to multiply to. So 4 times negative 12, if I add that up, it gives me negative 8. And then 6 times negative 8 is the same thing. It's going to give me the same number as 4 times negative 12 when I multiply those numbers together. So if I multiply A times C, it will give me the same numbers that add up to B. So what I'm going to write here, down here, I have A times C is equal to the two coefficients of our x terms multiplied together. So if we have an expression in the form ax squared plus bx plus c where a is not equal to 1, to go backwards to find the two coefficients of our x terms in expanded expression, because we have to go back to expanded expression in order to get back to factored form, we need to find two numbers that both, like I said, add up to b. So they need to add up to b. And they need to multiply to a times c. Multiply to a times c. So we can use the diamond again for this. We're going to use the diamond again for this. I need more space. The diamond again. We need two numbers that multiply to a times c and add up to b. But instead of going directly into factored form from this, this is going to tell us, the diamond will tell us one coefficient for one of our x terms in expanded form. And the coefficient for the other. X term in expanded form. So from this diamond, I'm not going to go directly to factored form. That's not going to happen. I'm going to have to go first to expanded form. Next to area square, and then back to factored form. So looking at this, I can't just go from simplified expression to factored form. It's I have to make my life more difficult. I have to do every one of these steps back. So let's do an example. I have 12x squared minus 2x minus 2, and I want to factor this thing. First thing I'm going to do, use the diamond. I need to find two numbers that multiply to 2 times negative 2, which is negative 24, and they have to add up to negative 2. Those two numbers are negative 6 and positive 4. That is not going to tell me that's not going to tell me factored form. That is going to tell me how I can break this simplified expression down into expanded form. So I know I still have the 12x squared at the front and the negative 2x at the end, but this negative 2x, I'm going to rewrite it as negative 6x plus 4x. So negative 6x plus 4x, that's changing too. From there, I can do my area square. Our area square has 4 boxes. Now we're going to go backwards from what we normally do. We're going to put these terms inside of the box, and then we're going to find the side lengths. The side lengths are going to tell us our factored form. I know always the x squared term goes in the top left, so 12x squared goes in the top left. I know always the constant goes at the bottom right, so I put negative 2 at the bottom right. 2 middle terms, doesn't matter where you put them, you can put them wherever you want. I'm going to put negative 6x here, and I'm going to put 4x here. From there, I'm going to find what works as the side lengths. I have to look at the 12x squared first. What two x terms multiply together to get 12x squared? Well, 12x times x would not work because no matter where I put 12x, if I put it here or I put it here, it won't work for either one of these. I can't multiply it by a whole number to get 4x or negative 6x. So I can't use 12x. So the next thing down would be 6x and 2x. So let's see if I could use that. Well, I couldn't put 6x here if I wanted to, but I could put 6x here because 6x times a whole number could give me negative 6x, but 6x times a whole number would not give me 4x. So I have 6x on the top, which means I would have 2x here. Let's see if that works. Well, 6x times what gives me negative 6x? 6x times negative 1. And 2x times what gives me 4x? I have 2x times 2. Wait, oh my god, I didn't write the negative 1. Does 2 times negative 1 give me negative 2? Yes, it does. So this works. And it's just guess and check after you, in the area square, you have to guess and check. Eventually you'll become so good at it that you don't even have to guess and check, and you can automatically see what it's going to be. But right now, now I know that these are my two factored form, these are my two parentheses in factored form. So I have 2x minus 1 times 6x plus 2 is my answer. All right, and then trying example 2, I want to factor this thing. So first thing I'm going to do, I'm going to use my diamond to find two numbers that multiply to 3 and 6, which is 18, or 3 times 6, which is 18. And they have to add up to 11. And those two numbers are 2 and 9. So I'm going to, now I know that this is not going to tell me directly factored form, since a is not equal to 1. This is going to tell me expanded form. So I know 2x plus 9x is how I can break down this 11x. I know that the first term, 3x squared, is the same, 6 is the same at the end, but 11x becomes plus 2x plus 9x. So instead of 11x, I have plus 2x plus 9x. I got that from here. All right, from there, I'm going to do my area square. Now I have 4 terms I could put into my area square. My area square, I always put the x squared term in the top left, 3x squared. I always put the constant in the bottom right. And it doesn't matter where I put the other two, but I'm going to put them like this. And then I'm going to ask myself, the first thing I need to focus on is that x squared term, 3x. What 3x squared, what two x terms multiply together to get that? The only option is 3x times x. So I need to decide, where do I put 3x? Well, I can't put it here because it's 3x times something to get 2x. That something would not be a whole number. I need whole numbers, so that doesn't work. So I got to put the 3x here by default. So 3x and then x on the top give me 3x squared. 3x times what gives me 9x? That is 3. And x times what gives me 2x? And that is 1. No, oh my god, 2. Does 3 times 2 give me 6? Yes, it does, so I've done this correctly. I have, then my factored form is 3x plus 2 times x plus 3. 3x plus 2 times x plus 3. and I'm done. All right, and then the last type of quadratic expression we're going to look at is the difference of two squares. So the difference of two squares, I'm going to do this all through and see what I get as my simplified expressions, and then I'm going to look for a pattern again. I have a factored form to area square. I'm multiplying the two together. I have x times x is x squared. X times 2 is 2x. Negative 2 times x, negative 2x, and negative 2 times 2 is negative 4. Expanded expression, I'm just adding all of these up. I get x squared plus 2x minus 2x minus 4. And then the simplified expression, I'm collecting those middle terms. Collectively, they are equal to 0. So they cancel each other out. And I'm left with just x squared minus 4. For this second example, I have 4x times 4x gives me 16x squared. 4x times 3x, 12x. 4x times negative 3 is negative 12x, and negative 3 times 3 is negative 9. And my expanded expression is 16x squared plus 12x minus 12x minus 9. I know that these two terms, if I add them together, it's equal to 0. They're opposites of each other, so my simplified expression is just the first term, 16x squared, minus the last term, 9. I want to look to see if there's a way that I can go from simplified expression back to factored forms. I want to make my life as easy as possible, so I really want there to be a way for me to go from simplified expression to factored form. So I'm going to see if I can find a pattern here. I have x squared minus 4, and is my simplified expression, and factored form is x plus 2 times x minus 2. Well, what I noticed about my two factored forms is that they start with the same thing and they end with the same thing. Oops. So they start with the same thing and they end with the same thing. So I probably can find those two things in my simplified expression somehow. Well, looking at my simplified expression, I have x squared minus 4. Where do I see x and 2 here? If I break down the first term, it breaks down into x times x, or x times itself. If I break down the second term, it breaks down into 2 times itself, 2 times 2. And I have the difference of that. So I really have the difference of x to the second power minus the difference of 2 to the second power, or the difference between x squared and 2 squared. The difference of two squares. Interesting. All right, in the second example, where do I see 4x and 3? Well, if I break down the first term, it's 4x times 4x gives me 16x squared. And if I break down the second term, it's 3 times 3. I'm doing the difference of that. Well, I could rewrite this as 4x squared minus 3 squared, the difference of two squares. So to go from simplified expression to factored form, I need to see what's being squared in the first term. What's being squared in the first term, that's going to be my first thing in my factored form. And then I'm going to look at what's being squared what's the second term, or what's being squared in the second term. And that's going to be the second term that I see in my factored form. Same thing here. 4x was being squared in the first term, so 4x is my first term in my factored form. And 3 is being squared in my second term, so 3 is the number I see in second in my factored form. So if we have an expression in the form ax squared minus by squared, to find our factored form, we look for what is being squared in the simplified form. Those are the numbers we see in factored form. So Also, if we look at the factored form, another pattern that I see is that I have plus or addition in the first parentheses and subtraction in the second. Addition in the first parentheses and subtraction in the second. So if I break down ax squared minus by squared into factored form, it's going to be ax is the first, so I have two parentheses. Ax is the first term, because that's the thing that's being squared first. By is the second term. I have in one parentheses addition, and then the other I have subtraction. So to recap, this is the first term, that's what's being squared, so that's the first term I see in my factored form. This is the second term that's being squared, so that's the second term that I see in my factored form. Right? And let's try examples. So example 1, I want to factor x squared minus 64. So I'm going to break this down. What's being squared here to get x squared? It's x times x. It's x squared gives me x squared. What is being squared to get 64? I have 8 squared gives me 64. So I have the difference between x squared and 8 squared. I know my factored form, first term is going to be x, second term is going to be 8. In one, I have addition, and in the other, I have subtraction. This is my factored form. For 4x squared minus 81, I have what's being squared here to get 4x squared. That is 2x times itself, so it's 2x to the second power. 81, what's that? What's being squared to get 81? 9 is being squared to get 81. I have the difference between 2x squared and 9x squared, and that means my first term in my factored form is 2x. That's taken from here. And my second term is 9. It's taken from here. I know how I have addition in one of the parentheses and subtraction in the other. This is my factored form. All right, to recap, to summarize all of that. First thing that I always do when I'm factoring, always look for the GCF first. So always do this first. Always. And GCF, just as a reminder, is what all the terms have in common. So you're going to find what all the terms have in common. And pull that out before you do anything else. For ax squared plus bx plus c, where a is equal to 1. Diamond. Directly to factored form. Easy. For ax squared plus bx plus c, where a is not equal to 1, you still start with the diamond, but you go back to expanded form. Then to the area square, then to factored form. You can't go directly from diamond to factored form when a is not equal to 1. And then the last thing, difference of two squares. If you have ax squared minus by squared, that's going to break down into the first term in your parentheses in factored form is ax. It's the first thing being squared. The second term is going to be by. In one, you'll have addition, and then the other, you'll have subtraction.